So this quick video will remind us some of the basics about triangles. So the first thing that we talked about, the triangle angle sum theorem, the sum of the angles in any triangle is always 180 degrees. So a very basic example here, if we're finding the missing angle there, what we can do, 130 plus 20 is 150, which means there's 180 minus 150. There are 30 degrees left for the missing triangle, so that would be 30 degrees. More than likely, you're going to have to do a little bit more with it. So here we have a linear pair as a reminder. Linear pairs add up to 180, so 180 minus 155 puts us at 25 degrees. So that tells us this angle inside the triangle is 25 degrees. And now it's just like number 29. So 133 plus 25 is 158, and then 180 minus 158 would be equal to 122, or 22, excuse me. So this missing angle right here is 22 degrees. All right. Another example for this particular one, again, we got a linear pair. So 180 minus 60 is 120. So 120 is the angle inside the triangle. And we're looking for this angle right here. And using vertical angles, we can move that question mark, or I'll put X there, to the inside. So again, it's a matter of figuring out. So we got 120 plus 30 is 150, which means 180 minus 150 puts us at 30 degrees for angle X. Involving some algebra with it, with some variables. Same idea, just a little bit of work involved, so we're going to have to add the angles up. So 55 plus 54 plus X plus 74 equals 180. So it's just a matter of combining some like terms. So 55 plus 54 plus 74 is 183 plus X equals 180. Move the 183 over, subtract 183, so X equals -3. And it's okay to get negatives. Here, kind of putting it all together, got to move that 43 to the inside. And so again, we got 43 plus 5 plus 14 plus X, or excuse me, plus 14X plus 9X minus 6 equals 180. Combine your like terms, so 43 plus 5 minus 6 is 42. 14X plus 9X is 23X equals 180. Subtract 42 from both sides. So 180 minus 42 is 138. So we got 23X goes 138. Divide both sides by 23. And you end up with X equals 6. We'll clean that up a little bit so it's easier to read. And then one more example. Using a vertical angle again. 17x minus 1 comes inside. So we have 80 plus 17x minus 1 plus 16x plus 2. That equals 180. So let's go ahead. We'll combine some like terms. So get the 80. You have to do minus 1 plus 2. So we have 81. 17 plus 16x will be plus 33x equals 180. Let me clean this up just a little bit so it's easier to read. So that's 17x minus 1 plus 16x plus 2. Combine those like terms like I said. Subtract 81 from both sides. So we're left with 33x equals 99. Divide both sides by 33. And here, x equals 3. Here, kind of squeezed in down at the bottom of this page, are a couple of proofs. Remember, you guys aren't going to have to necessarily come up with these by scratch, or from scratch, excuse me. But we do want to be able to kind of mark the picture with what's given. So we mark AD is congruent to CB. AB matches up with CD. And we're trying to prove those two triangles are congruent. So remember, the first reason is always given. And then the other thing that we're always allowed to mark is we're allowed to mark that shared side, which happens to pop up in number 2, where we marked AC is congruent to AC. Recall that this is where we would put the reflexive property when we mark the shared side. And now in step 3, why are those two triangles congruent? We'll look at the markings. You can see these are congruent by side, side, side. Here, X is the midpoint of CK, which means those two pieces are equal. Angle C is congruent to angle B, although I believe we need actually this to be angle K. I think I updated you there. So you'd put angle K and then update angle K right here. So the first reason is given. And then look back here, CX and XK. So why did we mark those two pieces congruent? Well, that was definition of midpoint. Alright, angle CXR. So why would this angle, CXR, be congruent to BXK? Well, that's one of those things that we're always kind of allowed to mark, which would be the vertical angles. So here, I'll even write it in red since I marked them in red. Vertical angles are congruent. And then we look closely at the triangle now that we've got it all marked. We've got ASA and ASA, which means those two triangles are congruent by ASA.